CLO for this lesson is that students will be able to graph in writing functions using the parent functions and transformations, as well as the following language. If then statements, parent function, transformation, translation, and reflection. So what do you think you're going to learn how to do in this lesson? Ah, for a quick reminder, a parent function is one of the main ones. Transformation means to change it. A translation is one way we can change a shape by moving it either up, down, left, or right. So translation's just the big word for move. And then reflection is the new one for these notes. So if we start on the vocabulary for the new one, the word reflection means to flip. So here's the thing about reflections, about flipping an image. There's tons of ways to reflect things. If I were to show you this first one, this blue one reflected over the x-axis, this side-to-side line, because it's all up here and it's like it straight flipped down. So it's like this point was 1 away from the x-axis, so it moved 1 away down here, versus this one was 3 up, and so it went 3 down. And so the whole thing flips down over the x-axis in this picture. In this one, it goes side to side. It goes over the y-axis, this up and down line. So it's like it flipped over from here over to here. So like this Q was the furthest away from the middle, just like it's the furthest away over here, because it got like flipped over the whole thing. So you can go over these two lines, the x-axis and the y-axis. You can reflect over those. You can also reflect over some random line. Like see this diagonal line? They could take this shape and make it flip over that. So it's like if you were to fold this paper where that diagonal line was, they would match up and they would be the same, like on top of each other. So there's ways to do all of these in equations, but the one that we're going to focus on is this one, which is called reflecting over the vertex. So where it's right where the vertex meets is where it flips over. Versus like these ones, they're not even touching. But this one, it's like flipping over right where the vertex is. So that's the type we're going to work on today. The transformation is reflecting over the vertex. So in an equation, what causes a function to reflect over the vertex? So the parent function is just the normal x cubed. So if I plugged -1 times it to -1 and times it to -1 again, we get out -1. But this negative in front takes it and makes it turn positive. For 0, 0 times 0 times 0 is 0. And then if I put a negative in front, well, -0 is still 0. When I put in +1 for the parent, 1 times 1 times 1 is just 1. But for the new one, if there's a negative in front of that 1 now, it becomes -1. So you see how this one was negative, but then became positive. And this one was positive and then became negative. The negative in front flips it. It makes it reflect. So if I were to graph the parent function, a cubic has this point at 0, 0, and it goes a right one, up 1. And then the third point is left and then down. And from that vertex, I'd S up on the right and then go down on the left. Now to graph my new one with the reflection in front, there's still 0, 0. But now at -1 on the left, it's not going down, it's going up. It's a positive one. And then for +1, instead of going up to +1, it's going down to -1. And so it's like it flips over. So instead of this on the left going down, now it's going to go up. And instead of going up on the right, now it's going to go down. So that reflected it, it flipped it. So instead of going up, it goes down. Instead of going down, it goes up. Flipped over. So to erase the parent function so you can see what the new graph looks like, that would be the answer for the reflected one for this graph. So the transformation in this was a reflection over the vertex. Parent function was the cubic because it had the x cubed. And the shape is the up and down sort of S that it made. And it got reflected, which means if we go to our major points to plot, all of these up, 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 and then these two being up and then down, these can change. Because if it's being reflected, then they switch. It wasn't right one up, it became right and then down, and then left and then up. So this is the normal way, but reflections change. Reflections change whether or not you go up or down. If they told you that the parent function was x cubed, the quick way to write it would then to be graph negative f of x, where the negative's in front of the equation. So I put this little note here that says you always start graphing by translating the vertex first, then you're going to reflect the next 2 points. So this one, it has multiple transformations in it. First of all, what's the parent function? Remember, this is an absolute value because of the 2 lines around it, which means which shape is it going to make? It's going to make this V type of shape. Now the transformations, there's a lot of them. There's 3. What are the 3 transformations? Well, the negative in front tells you to reflect around the vertex. It doesn't matter if you say around or over, they're just words. Then there's a translation right 5, because the minus 5 in the parenthesis means to go right. And the plus 2 at the end means to translate up 2. So to graph this, remember I have to start with translating my vertex. So I'm going to start by going right 1, 2, 3, 4, 5, and then up 2, and putting my 0, 0. Next, I'm going to look at my 2 points for absolute value. So for absolute value, they want the vertex, but then we translate it based on the transformations. Then it says write 1 up 1, but because it's being reflected, it's actually going to go down. Same thing here, left 1, down 1. So for both of them, I'm going to go right and then down to reflect it, and then left from the vertex and down so that it's getting reflected. And then I make the correct shape, which should be a perfect V. And then that would be the graph of this equation. The shifts of this equation, using notation, would be that they would say f of x is the absolute value of x. Therefore, you're going to graph, and then the negative in front for the reflection, then f of x, the absolute value, and then the minus 5 in the parentheses, then the plus 2 after the parentheses. So this means the exact same thing as this up here. It's just written differently. So before ending the notes, I'm going to quickly show you all of the parent functions being with nothing else but reflections. so you can see how their shape changes. I'm not going to do the constant, but the linear normally would have a point at 0, 0. Then it'll go over one, up one, but instead it's going to go down. Instead of left and down, it's going to go up. And then it's a straight line through there. That's not straight. Pretend it is. So if you look at Desmos, this is normal x, this is negative x. So instead of left to right, normal x goes up. But then with the negative, instead of left to right, it goes down. So the negative makes it go in the other direction. 4x squared, the positive makes it a u. The negative makes it turn over. Look at that blue one. It kind of looks like an N. So for x squared, there's a point at 0, 0. And then right one, down one. Left one, down one. So that when I make the shape, it's kind of like a flipped over U. Or like a little N type of thing. For the square root, normally is the top half of the U. But if I put a negative in front, it becomes the bottom half of it. It flips down like that. So for the square root, there's a point at 0, 0. And then over one, down one. And it's like the bottom half of that U. For the cubic, this is the positive version. This is the negative version. So the positive versus the negative. So the negative 0, 0. And then it's right and down. And left and up. So it's like it just flips the S going the other way. Same thing for the cube root. Instead of being right and up, it's right and down. And then it's left and up, which means instead of starting in the middle and going up when I go right, I start in the middle and I go down when I go right. And then it's up to the left. And then finally, the absolute value of x, instead of this v going up, both of those points are going to go down. So the v gets flipped over. Pretend like that's a perfect v, but it's not. And that's the reflected absolute value graph. So, using if-then statements, as well as the vocabulary words, explain what you learned how to do in this lesson.